Hello, friends. Welcome to this very dark room. I mean, I say very dark because I can hardly see you. I see you are there, but I'm like blinded by these lights. Welcome to the talk, to rag or not to rag. Briefly about myself. I am Piotr Przybył. I work as developer advocate for a company called Elastic, for search, observability, and other stuff, right? I'm also Java champion, test containers champion. You can find me in social media in like various places and so on. Let's be honest, this talk is somewhat like AI related, right? So if you ask the AI or ask on Blue Sky, this is what the AI thinks of me, right? That at least I'm authentic, at least mostly. I'm also like somewhat thought leader, mostly Java, and I also do community engagement. So I think this is like key topics. I don't know if I could be, if I like being a talking scarecrow, right? But I don't know, maybe I look like this. Sorry, I prefer like being this crazy scientist, hence the lab coat, right? I'm not a doctor. I'm more of I like to play experiments, right? Play it wild and so on. So this is to like remind us or keep us in this mindset. Who are you? Apart from the fact that you are people, you are not AI. Who's a developer? Almost everyone. Who's not a developer? That's okay. Are you a manager? Okay, we have a manager in the room. Thank you. Who's doing Java? Oh, sorry, let's who's not doing Java or Kotlin? Okay, one person, very nice, okay. Little warning, caveat auditoris, let the audience be aware, right? So these days, it's better not to trust talking heads, right, in talking to you from the screen because it might be, twisted or something. The other thing is, whatever I plan to say today, it might be irrelevant in a few weeks because of the rapid evolution of this whole thing, right, related to AI. And also, unfortunately, when I'm stressed, and I'm a bit stressed, despite you being very lovely people, sometimes I twist words when I'm, stressed. So if I say funny things, it's on me. If you would like to ask some questions, right, and so on, please remember we have Slido. So you have to join Slido, hashtag GeeCON, or GeeCON, no, sorry, this is not how you pronounce it. Select proper room, it's room number 1, I believe, and go on, right? Of course, I'll be, after the talk, also to answer your questions if you prefer, like, one-to-one communication. And now, sorry for those who doesn't speak Polish. Okay, I'm sorry for you folks. There will be, since we are in Krakow, we're in Poland, there will be like a small detour to Polish. If you're watching this on YouTube and you don't speak Polish, just fast forward a few moments. I will switch briefly to Polish, okay? But I think I have valid reasons. Przyjaciele, nie mówmy agenci AI, ok? Tam moim zdaniem są 2 błędy w tym. Proponowałbym, żebyśmy raczej mówili agenty SI. Z tego powodu, że jak macie serwerownię, to w środku nie siedzą serwerzy, tylko serwery, bo to są byty nieożywione, a dodatkowo nie ma powodu, żeby mówić AI, tylko możemy mówić SI. Ja wiem, że jak ktoś powie, tak, prawda, artificial intelligence albo AI z takim mocno zachodnim akcentem, to w ogóle tak brzmi, że o Jezu, ale jak mówimy sztuczna inteligencja, to może to bardziej oddaje znaczenie tego wszystkiego, czym to tak naprawdę jest. Szczególnie to słowo sztuczna, nie? Że to może wyglądać czasami trochę jak te sztuczne kwiaty, wiecie, zeszłoroczne na cmentarzu, gdzieś tam zapomniane, zakurzone na nagrobku. I dlaczego jeszcze o tym mówię? Szczególnie czuję się do tego zobowiązany, będąc tutaj, wiecie, w Krakowie, jak niektórzy mówią, w stolicy Polski i tak dalej. Widzicie, jak się otworzy niemiecką gazetę, tu macie Frankfurter Allgemeine Zeitung, to oni nie mówią AI, tylko mówią KI, Künstliche Intelligenz, prawda? Jak otworzycie Le Monde, to oni też tutaj, prawda, piszą sobie AI albo die Intelligence Artificielle, prawda? Więc też nie dają AI czy czy artificial intelligence, tylko tłumaczą to na francuski. Nawet jak byłem na wakacjach w Portugalii, ja przepraszam, ja nie znam portugalskiego, wam tego nie przeczytam, ale coś w rodzaju, albo spróbuję intelligencia artificial, prawda? Portugalczycy, dużo mniejsza nacja od naszej, nadal tłumaczą to na swoje, więc ja naprawdę nie rozumiem, dlaczego naród, który ma tak wielu noblistów i nie chcę tutaj uderzać w jakiś źle rozumiany nacjonalizm, i najwięcej chyba z dziedziny literatury i to jeszcze, prawda, będąc tutaj w Krakowie, że nie możemy powiedzieć generatywna SI, tylko trzeba wszędzie pisać AI, prawda? A tak samo tutaj, kolejny duży portal, tu nie wiem jaka to jest grupa, tu niektórzy mówią, że to jest grupa Der Onet, prawda, i tak dalej. I ja wiem, że są takie regionalizmy. Pytanie jest z sali. Tak, ale na tej amerykańskiej klawiaturze możesz nadal napisać SI, drogi Kubo. Ale też mogą napisać, prawda, w ten sposób. Co się da napisać po angielsku, da się napisać również po francusku, bo pracowałem na Azerty, więc wiem. O co mi chodzi? Nie wiem dlaczego we Wrocławiu, tam gdzie ja mieszkam w tych okolicach, jest jakieś takie, wiecie, ale niemieckie to dobre. Tutaj mam wrażenie taki bardziej kult mitel Europy. W Warszawie właśnie, że to amerykańskie to musi być dobre. Ja uważam, że my Polacy mamy prawo być kreatywni, pracowici, szanowani i tak dalej na swój własny sposób, więc zachęcam was serdecznie, mówmy sztuczna inteligencja, mówmy SI, a nie, prawda, że wszystko jak przychodzi skąd inąd, prawda, ze wschodu czy z zachodu, to brzmi dużo lepiej. This talk is in English, okay? It was just a brief detour. It was just brief detour. Yes, I'm switching to English because that was brief detour, to Polish, right? Sorry, it's just because this used to be a capital, and some say it's still cultural capital of Poland. So I felt obliged to give this little comment how to actually say and abbreviate artificial intelligence in Polish, okay? So let's go back to the talk, right? There was this other talk which I gave, for example, yesterday in Sofia, and it was about stream gatherers in Java, right? So I've taken this screenshot, right, a few months ago when I asked artificial intelligence, what are stream gatherers in Java? Do you know what stream gatherers are in Java? Okay, there's a very cool addition. We have now a new piece of API for intermediate operations in Stream API, right? Since Java 24, but there is a whole new talk about this. So anyway, I asked AI about this, and there it went. Stream gatherers in Java refer to techniques, blah 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 blah, and here's the answer. That smells like Java 8, right? And why did it happen? Well, because AI, or this particular model, has been trained when there was before there was a concept of stream gatherers, right, in modern Java. So that is why basically that is the reason, right? So it's hallucinating here, right? And here is the problem, the actual problem when it comes to training an actual use case, right? You are training for one situation, or the model has been trained for one situation, and there's actual use case being not necessarily the same thing. So what we can do, we can, of course, if something doesn't work, we can try doing it again, right? And so I did. So I repeated this very same thing like a few weeks ago, and it's still hallucinating because here it says to list, to set, to map, so it's clearly talking about collectors. It's even written here. Because semantically, in English, to gather and to collect is very, very closely, right? But if we go and do something like this suddenly it starts giving a proper answer, right? So it's a gatherer, input element, mutable state, yes, and so on. This is valid answer, right? This is valid answer. So can you tell me what's the difference between these two? I have nice elastic swag for active people. Not necessarily good answers, but just active people. Can you tell the difference between these two? Search. Who said search? Yes, so maybe I won't throw it that far away, okay? After the talk, please and come grab a webcam blinder. I have stickers, right, for everyone. It's just I also have a special swag for special attendees. Yes, this is the difference, right? The difference is basically here. If we enable the search, and the AI is so intelligent to go and grab proper context information, right? Something that appeared, for example, after it was trained, then suddenly it's able to generate correct or better answer, right? Let me put it this way. And this is basically, or can be named as retrieval augmented generation. It's a design pattern or architectural pattern, shall I better say. And I was told that people love this slide, especially the architects, because they are not only arrows, but they're animated, right? So it's extra points. Right? It's not the dreaded UML. So let's do this like they do the investigation. Let me do it backwards, right? What do we need to do to get the right answer here, right, from the Gen AI or large language model, right? We need to get proper data. So there is this knowledge, right, when it's trained, and let's assume this arrow and everything like before it doesn't exist. So we need to get like it's trained on public internet data, and we try to get an answer. And I have prepared a few demos, like code demos, right? Because in code we trust. And I know it's GeeCON. We're celebrating 15th anniversary of the conference and 30th anniversary of Java as a whole. But I've decided to create something a little bit unorthodox. Let me put it this way: who can tell me what is the language that the demos are written in? Don't be shy. Sorry? Python. It's the first language when people think AI. No, not Python. Sorry? PowerPoint. No, it's not a language. Sorry, I'm sorry. Someone has cheated to you.
Is it Bash?
Marit asks, is it Bash? Yes, it is. Did you know that? Okay, I might have. Sorry, I spoiled the talk. Yes. So I have written the demos in Bash, just to prove the point that you don't need any special libraries, any ecosystem, and so on. And for most of the cases, what you need is basically able to send or to make some HTTP requests, and that's basically it. So no matter what your technology is, right, you are able to use the AI, the language models, and so on. So what I'm doing here, I have Ollama running, or we can't see it. It should be somewhere in here, right? And I have, for my generating model, I have, what do I have? DeepSeek R1, right? So this is the model I'll be using to generate everything that's running here. Is running on my local machine. I'm not going to make any cloud or SaaS or whatever calls, right? So this is it. And now let me go back to this script. So this is the script, and let me run it, right? So what I'm going to do, as you can see, I have some checks if Ollama is running, if it has the generating model already downloaded, and so on. And then I'm making a request, a post request to API generate, and this is the JSON I'm sending, right? So this is the model, of course. This is the prompt, what are stream gatherers in Java, and these are options, and the only option I'm using here is temperature, okay? Temperature, I mean, I don't want into a proper, deep, scientifically correct description or explanation. Think, or my easy explanation of what temperature is, you can think it's like a YOLO factor, okay? The higher it is, the more YOLO it goes. The lower it is, the more it sticks or stays let's say, not inventing. So if you want to have I don't know, an advice when it comes to medical stuff or some, juridical stuff like laws and so on, you want to rather keep it cool in terms do not be that much creative. But when you need go wild, you go with a high temperature, right, between 0 and 1. So 0.6, it's the default, I think. So let me go and run it. Let me go and say generate 0, and I'm going to make this request, okay? And let's see if I can make it big. Yeah, as you can see, it's streaming the response, basically sending me batches in JSON. So this is what it does, right? It starts answering and so on. Let me stop it and maybe pipe it to this little stream printer I also created. So hopefully it will be more illustrative what it does. See, and this is it. So I'm trying to understand what a string gather is in Java from what I remember, right? This is like the reasoning phase you can see with this thing tag, right? Right in top, right? And there it goes, like for each, collect, reduce, and so on. So just like ChatGPT without search, right now it's like hallucinating, basically trying to get the best answer, including the data it was trained on, right? The public data. Maybe I should stop it here, right? So this is what it basically does, right? And now it's time for this your question and context window. So this is going to be like a sort of like a mental shortcut, right? Let's assume that this LLM is actually like intelligent, okay? So just as you are an intelligent person, and you can ask questions to yourself or to somebody else, for example, hey, this is my company's policy, like holiday policy or compensation policy. Am I able to expense X? Or do I have extra days for this and that event, for example, or like for my wedding or something like this? And of course, ChatGPT or any other LLM won't know it unless it was trained on your corporate or company or your organization data, right? But if it's somewhat intelligent, what you can do is the following. You can find the relevant pages. Let's say we have printed it, right? Or we can have it like in Wiki. And then we find these pages. We take these, let's say, 3 pages out of this huge book, right? And we hand it over to the AI. All right, and then the AI, being like trained to be intelligent, right, can also take these extra pages it was given as a context, and based on this, it can generate better answer, right? So so we get the proper context as depicted here, right? And the context comes from like, or is based on your question, and it's coming from your business data, which can be anything, like documents, images, audio files, like whatever you can make searchable here, right? Because the context is the king, right? So based on this, once we ingested this data and processed it to whatever, once we find it using whatever technique, we hand this, like we identify these 3 pages, and we give it to the AI, and the AI is able to give us correct answer. So let's revisit the example, and let's go for another script. And what I'm doing here is, I know, right, because fun fact, like I gave this talk, that there is this JEP 485 about string gatherers, right? So what I can do is the following. I can grab this knowledge from the internet, right? And then I can create the prompt, given the context information provided below, answer the following user prompt in English. Here's the prompt. It's still the same, what are string gatherers in Java, and here's the context information that follows, and that's the HTML content of this page, okay? And then I will just print it, the whole prompt, and we'll see what the lovely AI of ours will be able to do, right? So let me go generate 1, okay? And let's see what happens. Do I have the internet? Is it working? That's the thing. Okay, it is working. So I fetched, okay, there's a timeout 10 seconds. I remember now, like from the OpenGDK. So this, as you can see, is the prompt. So this is the context, right? The whole page, right? We skip the HTML formatting and so on. And here's the question, and we should be receiving the answer shortly. Which means we have some time for some dad jokes, right? I will show later my form, so if you have any dad jokes, please share with them, because I'm a dad joke connoisseur, and I'm sorry we don't have any more time. But you can see now what is happening, right? It just says, okay, I'm trying to understand this concept of gatherers, right? And here it is, gatherer definition, right? Object that implements a specific interface, gatherer, right? And it has this initializer, integrator, combiner, finisher, and that is correct, right? So it was able to get this 1 page, right? And now it's generating an answer that is augmented by this very knowledge, right? So suddenly it's not hallucinating anymore. It's giving us correct answer, right? And as you can see, the only thing that is like not bash here is the CURL and JQ, right? Because handling JSON in pure Bash, it's like a madness, just like in pure Java, right? Good luck. Yeah, here I'm just getting the context, the content of the main, like a main body. Okay, let's stop it here and let's go back to the slides. Okay, so here we are. Sorry, small Polish detour, right? Because people sometimes don't like understand what it really means, this retrieval augmented generation. So I asked ChatGPT, hey, what do you think it is in Polish? And it would be this. Generowanie wspomagane wyszukiwaniem. So we generate the answer, and it's basically augmented or improved by searching through stuff, right? So in the previous example, I cheated because I know exactly these 3 pages. I know exactly this URL, right? So the whole point of having like a proper RAG is to have the searching component, right? So how do we search through the data we have or we can have, right? Context is king, my friends, right? It's really important to find these 3 pages. I mean, I keep saying 3 pages. This could be like, of course, it depends on like your use case, your domain, and so on. If I say football here, right, in Poland or generally in Europe, people understand what it means, and it's, you know, this person, right? However, if I say it in the US of A, football there means something more like this, right? So please remember the context is important, right? And it's also like, how do we search for this data? Do you recognize the language? Nobody. No, I'm so. What happened to you? Everyone is like suddenly a front-end developer or what? Come on. What language is this? Yes, very well. Finally, you're interacting. Yeah, thank you. Yes. The thing is, if we have a query like this, because let's say the user typed you like a few words or 2 words, and based on this, like using ORM or whatever, right, and making sure there's no SQL injection, you created this query, right? But it will yield you or give you 2 results. It will give you milk chocolate, right? But it can also find chocolate milk. And now, do you know what the user was looking for? See, so now we are like going into this part where actually the meaning, the semantics of the whole thing might matter, right? Because when we go back to this like animated arrows chart, right, it's important to grasp the meaning, like the semantics of the question, to be able to find the correct pages, right, or correct pieces of our, let's say, internal knowledge library of something. So here we are, let's say, one of the ways of doing this is the vector search. So it's, who has worked with vector search so far? Sorry, I'm blinded. Okay, a few people. All right, so a little shameless plug. We have Elastic Meetup today at 6, right, in Krakow. If you're headed to GeeCON party, I'll be diving deeply or deeper into vector search. Here is just quick recap, so we try to like comprehend, basically. And this is when I say vector search today, from now on, I mean dense vectors, okay? I don't mean sparse vectors like else or other stuff. And this is the dense vector. So let's say this is our like space. We have just one dimensional space, and one side is realistic objects, meaning they look realistic, right? We of course know Princess Leia wasn't realistic, right? And we have this animated or cartoonish Darth Vader, right? So they represent the opposites, right, in this spectrum, right? So if we have just one dimension, this is the vector representation of these concepts, pictures, characters, whatever we name it, right? If we add another dimension, right, when we have sorry, I'm more like a Star Trek guy. Who is this? Is it Obi-Wan Kenobi? Yes, Obi-Wan Kenobi. Then he's human, but he's cartoonish, right? Whereas this android it seems or looks realistic, but it's machine, right? And then we can put more like this, and the data is grouped together, right? As you can see. So Darth Vader is like somewhat, or can be like a bit more machine than human, right? Whereas when we put what's his name? Skywalker, sorry. Yes, thank you very much. He is, as you can see, not entirely human. Why? His hand, exactly. His hand, his like this artificial hand, right, or prosthetics or whatever we call it, made it for his 20% or like 0.2 less human than Princess Leia. And so the story goes, right? We can add dimensions. So now we can imagine instead of just 2 dimensions, we have, let's say, 384, 512, or I don't know, 4,000 or something like this, right? And this is how it actually looks like, right? So if I make this query, I don't know if I shall be making this query, but let me allow me to do this, to run this script called encoder. Let me just show it to you. Oh yes, it's the whole script, right? See? So what I'm doing, I'm just calling another model, not the generating one, right? Just to give me an answer, and I have this get embedding, which should be like somewhere in one of the shell files. But basically, it's doing this, right? I'm calling not generate, but embeddings, and in this model, for this prompt, we generate me an embedding. An embedding is basically a numerical representation, as the model sees this, of the whole prompt. And the prompt can be, again, text, image, audio, like whatever it was trained to accept. There are models which are able to accept, like, for example, images and text at the same time, right? And so on. So what it gives us is basically an array. It gives us a vector representation. In this very case, or most of the cases, these are floating numbers, but they can be like I don't know, other vector, like let's say integers and so on, right? So if I go and call this, what was it called? Encoder.sh here. Okay, no text to generate embedding 4. Let me go and go stream gatherers, right? It will generate this very embedding, right? So basically a bunch of numbers. And they also have dimensions and so on and so on. Righty. One important thing, I mean, there are many important things, is just they are not working as prefixes, right? So as you can see, when I go and jumped over lazy programmer, but not dog, I mean, programmers can also be lazy, right? We are lazy at times, let's be honest. As you can see, it's not that it changes, I mean, the numbers change somewhere, you know, at the very end. They change from the very beginning, because when we have this multi-dimensional space, the whole meaning is like put here, or here, or here. So all the coordinates can change, right? And of course, the closer the vectors are, the more similar they are, right? Now, I was thinking how to express it in a different way when your granny asks this, right? Or like someone non-IT. Do you recognize this scene? What is it? Matrix. Who said Matrix? Very nice. 2 people. Okay, I have enough swag. Please both come. Yeah, Matrix, right? Matrix, the movie, the first one. Okay, so this is like the semantics, right? The whole thing, and this is the representation. Okay? Makes sense? I hope so. Right? So as you can see, you already know this. You just like there's now the whole like apparatus around this and like nomenclature and whatnot. And of course, there are like many vector stores. Elasticsearch is one of them. I would say it's pretty decent, if not one of the best. And it's not doing actually the whole thing on its own. It's using Lucene under the hood, and Lucene is doing like the actual storage, right? Whereas Elastic is doing like everything, you know, like the sharding, clusters, you know, scoring, distribution, and stuff like this. And so how it works is basically this, right? Let's recap this. We have these pieces of information, right? We have to create vector representations for this information, right? And then when we have our query, use the same model to create vector representation of the query, as you have just seen, and then we run a so-called vector search, right? Using the nearest neighbor, for example, and then we get the results. And these are the pages we're going to give to this LLM, right? And now it's like these 2 slides. There are many things which you have to consider, many aspects of models, right? We're generating these embeddings, for example. You can't just pick one or whatever or random one. It all matters. There are many factors, right? the key things I would say, if you start using this model, you can't switch to this model, right? Because it also gives me, let's say, 100 numbers. But these are different numbers, right? These coordinates mean something totally different than in this model, right? And of course, there's more and more and more. So this is like the absolute number one thing is don't switch the models in the middle, right? Use the same model for creating the representation and querying then later. Okay. Let me just show you quickly what I mean. So there's how I did it is basically I have run a little crawler script, right? And this, sorry, I'm going to show you now, right, Elastic, right? Or better said, this is Kibana. This is the UI for Elasticsearch. So I have this index. It's called my index JEPs. What I have here is just because I was like web crawling the JEP pages. So I have body, headings, ID, links, title, and so on, right? So this is what I have. And when we go to Discover and I search, for example, for this JEP 485, again, you see this document, right? And this is what I have there, right? The body, the headings, yeah, this is basically it. And this is not enough to run a vector search. This is enough to run the classic search, right? The term search, BM24/5, whatever we call it. To actually run a vector search, what I have to do is I have to enrich these documents with these representations. But let's run this quick thingy. Maybe I spoiled it. When this is our data, right? And the query is Han Solo, what do you think the answers will be? Cartoonish machine? I'm afraid not. It's position number 4, right? So the most human and realistic, it's assumed that here that Han Solo is human and realistic, so then Princess Leia is the most, the most relevant answer, right? Or hit, then it's Skywalker, and so on and so on. So here the story goes. So you get like the nearest neighbor, and then this there should be like a more further away in terms of distance for this model, right? So we get here, and this is what I told you, right? So to find this properly using vector search, we need to create vector representations of this. So there are many ways, right? You can, when you have paid features for Elasticsearch, you can go and create like ingestion pipeline and so on and so on. You can use semantic text. You can use sparse vectors and so on. The most, I would say, elemental way, if you have like a free and unpaid version, or that should work with any vector storage, is this. Something like I call a document enricher here, and it does two things. First, it creates this target index, right? So it will create for me another index, and this index is called here JEPs with embeddings. Right, so this is the second index, and because I'm not replacing or enhancing the documents in like where they are. I just copy them to a new index. Right, this is my approach, and give some extra vector data. Right, so this is the target index, and what does it do? Is where are you? Where are you? Let me find you. It should be this thing. So it's the original mapping, plus I add a few more fields. I add title embedding, which is dense vector, right, 348 dimensions, right, with cosine similarity. And then I also do body chunks. And this is another part of like, if you don't have to bother with this if you're going for semantic text. But anyway, do you know that body is huge or can be huge, right? So good luck with representing the meaning of the whole body using 384 floating numbers. So what we have to do, we have to chunk it, right, into like, I don't know, let's say passages or whatever, and then we have like this vector representation for every passage, right? There are different techniques for this chunking and so on. So basically I have this, like, I say it like it's a passage, and every passage has its vector representation, right? And I have just one for titles because the titles are rather short usually. And then when I do it, what I basically do, I should have a nice while loop. I just go for every document, right, in my original index. I contact the Olama for this to generate me the embeddings for this text, and then Olama doesn't know whether it's title, a chunk of body, or whatever. And then basically using some optimization techniques like bulk requests and so on, I enhance or enrich the data with vectors, right? So we should be able to see this as well, I hope. Let's go and click here like this. Discovery, let's just click a random jab, and as you can see I have these body chunks here, and this is like the chunk right I have here, and when we scroll down, this is the predicted value or vector representation for this very chunk for these few sentences, right? And there is for a similar one for another chunk, and so on and so on. So then I'm able to find relevant jabs based on something. So I have my data enriched with vectors right here, so it's searchable based on this your question thingy. So sorry, let me now just go and call this RAG script. Okay, and what I'm doing here, what is this RAG doing? Right, again, it's like see, let's say only 100 lines minus some like sanity checks and so on. Yeah, I have these checks, generating embeddings, searching, and this stream printer again. And what it does is, of course, checking stuff are properly set up. If I have Elasticsearch and Olama connectivity. By the way, I didn't show this. Thanks for reminding line 38. If we go here, see here, it is localhost, or as some German people say it, localhost, right? If you want to run Elasticsearch for, of course, evaluation purposes, this is not production, you can go for Elastic local, not local, sorry, I suck at typing, a local start, right? And there is a GitHub project right in here. It just, as long as you have Docker, you run this single command and you have the latest Elasticsearch running, okay? This is how you do that. Anyway, let me go back to this script, right? So we're testing if we have Elasticsearch running, if we have Olama connectivity as well, and then what I'm doing here, then this is like the mumbo jumbo, like pull these models if they are not there in Olama, and what I have basically in this regard, Olama is like a runtime for these models that can generate embeddings or generate answers, right, and so on. And then this is what we've seen before, right? Given the context information below and so on. It's just now I don't like give it, this is the URL, and fetch the body of the URL. I find the body of the document using this vector search, right? So here you can see this perform vector search, right? This is it, using this KNN query technique and so on, which is again, let me actually find this. I shall have it, what shortcut it is, Command-Shift-F, right? And should be here, right? So as you can see here, what I'm doing here again is nothing else but, yeah, this query. So it's like a JSON as a language, right? And then I make like a CUR request, and that's it, right? And I get like a response in JSON again. Right, so after doing all this, this is my context, right? These are the documents I have found. So now let me run it again. And let's go and say rag.sh and enter your prompt. What are stream gatherers in Java? Boom. And see, it found the relevant documents, and it found it really, really quickly, right? So I have like the preview ones and so on, and now it will be getting the answer from the LLM, which I hope gives us time for at least one dad joke, which I brought for you from Denver, Colorado, right? You know the joke, but it's a great joke. Star Trek question. How many ears did Captain Kirk have? Someone said 2. No. Captain Kirk had 3 ears. Left ear, right ear, and the final front ear. Yes, it's that bad, I know. Yeah. What we see here is now see, the thing is like enter this reasoning phase, right? Okay, I'm trying to understand this new feature in Java called gatherers, right? From what I gather, no pun intended, right? It's even like humorous to a certain degree. Yes, and it found this window sliding is interesting and so on. It's gatherers of sequential, so it's not hallucinating. It's like it's trying to comprehend these 3 documents, these 3 pages we found from our local vector store, right? And based on this extra context knowledge, I will say it again, context is the king, right? It tries to give us or generate for us the proper answer, right? And let me remind you that in this very case, it's rather simple because we just web crawled one page and that's really, really it, right? But we can have much more in this. We can have like, basically we can put the documents, right? Or like vector representations reflecting many sources. Your wiki page, right? I don't know, like laws in Poland passed since the LLM was trained, right? Some images, if you're running, for example, an e-commerce store and you need to like show, for example, descriptions of these images, which we will do with Marit like in a month from now, right? Yes, and see, this is like, yeah, it gives us, and this is the very correct answer, right? Yes, and it's generating it like parallel use, efficiency, and it finished, right? So it took quite some time while I was talking to you, and it's the correct answer. It wasn't hallucinating, right? So this, like if we compare this with this thing, which was like a total utter nonsense, with this thing, it's like the from 0 to hero improvement of quality. So all that was needed was this. And I spoiled it again. Oh, I'm sorry. Was this retrieval, right? So we augmented the generation with the retrieval. The question is, should I always RAG, right? And people say, yeah, you should RAG or something. And so some people will say, oh, you shouldn't. I would say it depends, right? In many cases, I mean, if you need to the frame question like this, always RAG, I would say probably not. And let me go back to this example. I didn't put any timestamps or something. Do you remember how quickly we received this thing? It was basically instant, right? So I'm not running it like a cloud setup, you know, sophisticated GPU stuff. It's all running here on this like desktop M3 machine, right? This was quick, right? And then let's assume I'm like intelligent human being, right? And then I can see, so you found for me these documents, this I don't know, wiki pages, these references to local law or whatever. I can click and read it and understand on my own. Do I really need the LLM, right? The Gen AI thingy to sort of like parse it, process it, and then give me yet another answer? In many cases, probably not, right? So I've seen usages, I can like show it to you because, you know, NDA and stuff, where what some people do in their interfaces is just, for example, next to us, like in the search area, they have not just like this text field, but they also say, for example, use this vector technique, use another vector technique, and this is like sometimes you don't know how to aid your user with finding the relevant data, right? So maybe these new searching techniques, and not just in Elasticsearch, but if your database supports it and so on, you can go for it, right? Might be in many cases just enough, and you don't need to spend money or generate CO2 just to be fancy and have this, you know, resume-driven development. Yes, RAG checked, okay? But if you need to go RAG, as you can see, it's really nothing fancy, right? You can basically get the context, right, using searching technique that whatever works for you, and then send it as context to this generating LLM, and that's basically it, right? And you can do it even from Bash, right? So there's nothing super fancy about this. Yes, and of course there's like more things, right? We are also like reaching this MCP thingy, so because the users might be like not knowing what they're looking for. There's of course this technique called hybrid search, when you combine, you know, these search approaches. I mean the good old ones and the new ones, and so on and so on. And there's this question, I don't know if someone asked this question in general about this Gen AI thingy or AI thingy in our industry in IT as well, right? And the frequent question is, okay, so once we implement all of this, right, and we'll have this very, sophisticated systems, or let me rephrase it, that's the systems that are able to give sophisticated answers, right, using very rudimentary architectural patterns, will I be needed, right? Will my job be needed, right? So I would say the whole AI thing is kind of like a sword, right? It has two edges. So if you frame the question like, will I lose my job because of AI, and it's not me who gave the answer, by the way, the answer would be, chances are that you are much more likely to lose the job because of the person next to you can actually use the AI, right? So it turns out that it's like, probably like a new skill, right? We need to keep in our sleeve or in our pocket, right? Not just to be able to use databases, right? Or I don't know, sophisticated coding techniques, but also have like an idea how to employ AI and how to put it in like our product space in general, so it makes sense or not. There are a few more thingies. If you are interested about more things related to Elastic's stuff, please go to our forum, which is Discuss Elastic CEO. Right, we answer questions there related to open source and free stuff. Or if you're more like Slacky person, you can go and join us on Slack. We also run a meetups in Poland, Warsaw, and Krakow. So the next one will happen in 2 hours in Krakow. If you're going to GeeCON party, you can drop by. We'll have some pizzas and whatnot. This is the URL for everything: the meetups, the Slack, the Discuss. Right, you can tag me there if you need. I also run a thing called BBL, which is like if you like your company has like an office in a city where we don't have meetups, we can run meetup like during lunchtime in your venue for free, like no ODA, no NDA, no such things, right? And it's time for feedback. If you're watching this on YouTube, please do 2 things. First, let me know how did you like this talk, right? This is like anonymous Google form, so let me know how it went, and don't forget to hit the subscribe button for GeeCON's channel, right? And the bell icon. And now I guess it's time for Slido, right? If we have any more questions. Sorry, is it this thing? Okay. So the question is, why 384? This is a good question. So it's because this model gives embeddings using 384 dimensional vectors, and that's really it, right? So the vectors can differ in size, and not always the larger means better. Sometimes you want to lose precision because, for example, you lose, like, let's say, 3% of precision, but you save lots of money and response time and so on. So as far as I remember, currently, Lucene, and therefore Elasticsearch supports up to 4096 dimensions, but I've seen case studies when getting like longer not necessarily means better, okay, in terms of dimensions. What did you use to generate images? I don't remember. I think it was this ChatGPT thingy. I paid $20, so I needed to get it back somehow. So that's the whole answer, right? What's the next question? How to assess that vector search results are relevant, and then search will always return something? Yes, if those results are relevant, there is no point in ragging. Yes, exactly. And this is one of the things, like, it basically means choose your models correctly, right? So you can't go for whatever model. You remember these 2 slides with the map, right? You need to choose a proper model that understands your domain and will give you relevant hits, right? And then it's time for these people who actually were like lab coats, and they are called data scientists, right? Maybe you need to hire one or employ one, because then they will help you to understand it and to go proper, engineering and science, and actually have like that results mean something and they are not rubbish, right? So that's the thing. Because of course, when you go like garbage in, you will get garbage out, and there's no point in ragging. Yes. Are embeddings the representations of our query, or maybe the result? Embedding is like the shortcut. Sorry if I like mix both of them. Is basically embedding can be like the same as vector representation. So you need to have vector representation, aka embedding for your data, and also we create a vector representation slash embedding, like let's say vector representation for your query. And then you just see have array of floating numbers, or just array of numbers, and you find the closest ones, right? Using like, I don't know, cosine, dot product, and whatnot. So this is how they work. I will dive deeper today at our meetup, right? Sorry for advertising again. Vectors seem bigger than a word. How big can be a final embedding data? Yes, as I told you, the biggest one is 4K right now, and therefore you need to chunk your data or make sure it's properly represented. And the chunking, like going into these pieces that has to have the representation is yet another like a research area. Can we get the scripts? Sorry, the one from the bottom. Yes, the scripts are on my GitHub. But these are not production ready, okay? So just keep that in mind. These are like to show like you have a funny demo, right? In unorthodox approach, hoping that I'm able to tell you or show you actually that you don't need any sophisticated Pythonish, Javish, or whatever API. You're able to make HTTP request, and that's it, right? That's really it. So you can write it in COBOL. I don't know if you have time for any more questions because time's up. So it's up to the organizers. Maybe I would say the following. I'll be here around, right? So for like half an hour or something, so try to find me. I'll try to answer some questions perhaps as well. Let's be mindful about the time. Sorry I didn't answer them all. Dziękuję wam bardzo. Thanks a lot. Sorry, please don't forget to grab some, like, I have like stickers, like smartphone stands, like cam blinders, whatever works for you. Thank you.